Welcome back, mathematicians. In this lesson, we're learning how to perform operations with functions. Remember that we write functions with function notation such as f of x and g of x. We're using function notation to distinguish between two entirely different functions. If we wrote these as y equals and y equals, we would be saying they are equal to each other, and they are not. So function notation gives us a much bigger variety to choose from. Today, we're going to be doing function operations, adding, subtracting, multiplying, and dividing. We will be doing the sum of these two functions, then taking the difference of these two functions, the product, and the quotient. Again, just meaning multiply and divide. Quotient is that fancy word for division. Each time, we'll simplify the new expression, and then we'll talk about one of the most important parts, the domain. If you're a little bit confused about finding domain and range of functions, you might want to look up my domain and range video on functions. When we combine functions, we have to make sure we only include x values that work for both functions. And in the case of division, we'll also need to exclude any x values that make the denominator 0, since you cannot divide by 0. Let's get started with the sum. So the first thing we need to do is recognize this notation. The beginning parentheses in this notation is telling us what to do with this function and what to do with this function. Now, it's a little bit funny because what they're really saying to do is take f of x and add it to g of x. But they've put it into this shortened notation. The reason that we do this, the best explanation I can come up with, is that mathematicians are inherently lazy. We don't like to write extra notation if we don't have to. So they've come up with this really easy way to see what are we actually doing with these two notations. So all we have to do is get right to work adding these two functions together. F of x is x cubed plus x, and that's being added to g of x, which is 2x plus 6. It's as simple as that. What we're going to do now is combine like terms. So remember that if it has an exponent that's different than the other ones, it cannot be combined. So x cubed is its own term. Plus x and positive 2x make 3x's. And then we have plus 6 as our last term. The really good news about this one is that no matter what you put in for x, you are going to get a number out for y. There is nothing that is undefined. And you could test out some values and really think about it. You could even graph it. But in the end, this is going to have a domain of all real numbers. Remember that if this is a little bit confusing to you, to go look up my video on domain and range. Let's go ahead and do a difference. In this one, we are going to find the difference between the two. Remember that this notation means f of x minus g of x. F of x again is x cubed plus x, and we are going to subtract. Now this part is important. A common mistake that students make is to hit the subtract button here and then simply put 2x plus 6. But remember, that's not what this says. This says you're supposed to subtract the entire g of x function, which means that we need to make sure to treat this like it is in a parentheses. We're subtracting the whole function. That's going to change the sign of everything that's inside of g of x. So this is minus 2x, and this negative is going to distribute and create a negative 6. So that's a really important distinction. Again, there are no other x cubes. 1x minus 2x's leaves a single negative x, and now we have negative 6. Again, since this is a cubic function, there are no values for x that make this undefined. So our domain is going to be all real numbers. Let's try the product. Now the product is going to take a little bit of extra work. We need to think about the product as two binomials multiplying each other. Remember, this is going to be f of x times g of x. So we can put the first function in parentheses, x cubed plus x, and the second function in parentheses, 2x plus 6. Each of these has to multiply in both terms. In fact, I'm going to move this function out of the way so that I have a little bit of room for some arrows. When you multiply binomials with each other, you take the first term and you multiply it times both of the second term. So that's going to be x cubed times 2x and x cubed times positive 6. You're then going to take the second term and multiply that times each term in the second binomial. So this is going to be an x times 2x and an x times positive 6. Now we've done the hard work. We're going to multiply these together. X cubed times 2x. Remember to multiply the coefficients together first. There's an invisible 1 right here. 1 times 2 is 2. When you multiply, you add the exponents. A lot of my students accidentally forget that there is an invisible 1 here as well. That 1 likes to hide behind a lot of stuff. So we actually have 4 total x's when we're done multiplying. There's an invisible 1 here as well. 1 times 6 is 6, and there aren't any more x's, so this is 6x cubed. There's an invisible 1 here, and 1 times 2 is 2. And remember, there's 1 here and here, so we have 2 x's when we're done multiplying. Everything so far has been positive. There's an invisible 1 here, and 1 times 6 is 6, and there's a single x here, so it's 6x. Now, the cool thing about this is it ended up having no like terms that needs to be combined. So our final answer is 2x to the 4th plus 6x cubed plus 2x squared plus 6x. And since this is just a quartic function, we also have a domain of all real numbers. Again, that means that we can plug anything we want in for x, and it's not going to make the function undefined. And now we're going to take the product. The product requires just a little bit of an extra step to determine what the domain is. So we're going to start off by describing the product over here so we have a little bit of extra space on the right hand side. Remember that this is f divided by g. Remember that fractions are really little miniature division signs, so we're going to divide f of x divided by g of x, and we're going to plug in our functions. So we have x cubed plus x over 2 x plus 6. In this case, we could, if we wanted to, factor out an x, which would leave us with x squared plus 1, and on the bottom, factor out a 2, which leaves us with x plus 3. In some cases, this is going to mean that we have some things we could simplify. In this case, that's not true, but I wanted to make sure to make a note to check your factoring to see if there's any simplification that needs to happen. Either way, what we have to do to determine the domain is we have to make sure that we could plug anything in for this and it would not become undefined. So that's true about the numerator. All the numbers of the numerator are just going to result in an integer. In the denominator, that's also true, except if we plug something into the denominator that causes this to be 0, it will create an undefined function. So to do the domain of a quotient, we have to make sure that the denominator is not 0. So we're going to take what the denominator is equal to and set it equal to 0 to find out what we would have to put in order to make it undefined. If we subtract 3 from both sides, we end up with x equals -3. That means that our domain is all real numbers. Anything else would work here, except x cannot equal -3. And this is the final answer for our domain. I hope that helps a little bit with operations with functions. Don't forget to like and subscribe. And of course, reach out in the comments if you have any more questions.